All right, so in the last video, we were doing logarithmic equations, and we used the quotient rule to solve this one because we have two logarithms with the same base with a subtraction sign in between. Now the next problem, number 4, doesn't involve any of that. You just have two logarithmic expressions. You're going to have log base 5 of 7x minus 9 equal to log base 5 of x squared minus x minus 29. Now to start off with, both of these have the same base, right? I'll circle it. This one has a base of 5 and this one has a base of 5. So what we're going to do is we're going to bring that base down and make it the new base for an exponential expression. Now the logarithm is going to be the exponent. So I have log base 5 of 7x minus 9. So I write log base 5 of 7x minus 9. And that is equal to 5 to the exponent of this logarithm, log base 5 of x squared minus x minus 29. So now what happens is on the left side, I have a 5 as the base and I have a 5 as the base of the logarithm. So they cancel out. Whatever's on the inside of the parentheses is going to come down, the 7x minus 9. Over on the right side, we have the same thing going on. We have a base of 5 being canceled out with this base of 5, leaving me with x squared minus x minus 29. So now to solve this equation, I want to try to get everything on one side and see if I can find the roots of this polynomial. Because if I can make this side into 0, then I can see if I can factor the right side. But to do that, I need to get rid of everything on the left side. So I do need to get rid of this 7x. We can subtract x from both sides to do that. And then to get rid of this minus 9, we can add 9 to both sides. So what happens is the entire left side gets canceled out because 7x minus 7x is going to give you 0. Negative 9 plus 9 is going to give you 0. So the left side is just going to be equal to 0. And everything else shows up on the right side. The x squared, the minus x minus 7x, that gives you minus 8x. And then the minus 29 plus 9, that's minus 20. Okay, so to factor this, I need to find two numbers that multiply to negative 20 but add up to negative 8. So what two numbers am I going to choose? Some kind of 2 and some kind of 10. I'm trying to multiply to 20, so I know I'm going to have to use 2 and 10. But which one has to be negative? Well, we're adding up to a negative 8, right? So the biggest number has to be negative. And the 2 is the smallest number, so it gets the plus in the middle. But everything is still equal to 0. So now I'm going to have two different equations. I'm going to have x plus 2 equals 0, and I'm going to have x minus 10 equals 0. When I solve the first one, I get 0 minus 2. That's going to give me x equals negative 2. And then on the other side, I'm going to have x minus 10 is equal to 0. I can add 10 to both sides. The 10s cancel out, and I'm left with x equals 0 plus 10, which is 10. So my solution set is just going to be negative 2 and 10. Okay, so to check our work, I really only want to check one of these. It's the negative 2. And I'll kind of show you why that is. because when I plug it back into our expression, log base 5 of 7x minus 9, here's what I get. I get log base 5 of 7 times negative 2 minus 9. And that's going to give me a negative 14 minus 9. That's negative 23. So really, I'm taking the logarithm of a negative number, negative 23, that is undefined. So I can't use that one. That's why the negative 2 can't be inside the solution set. So the only answer is going to be 10. So let's see how that works. Now I'm going to check with 10. So I let x equal 10. My original equation was log base 5 of 7x minus 9. I'll replace that x with a 10. And then that should be equal to log base 5 of 10 squared minus 10 minus 29. So are these two sides equal? Well, the first expression is going to give me 7 times 10. That's 70. 70 minus 9 would be 61. So then what would this expression be? If it's 61, then it'll work. I have 10 squared, which is 100. 100 minus 10 is 90. And then 90 minus 29 is going to give me that 61 that I want. So this just tells me that this is a true statement and that x equals 10 belongs in the solution set for this one. So it is a solution for the equation.